Long, long ago, before mankind, before the dinosaurs and before life itself, there was a void in the place and home we now call Earth. Through human ingenuity, various theories have emerged that try to explain the origin of the Earth, including the universe, some of which may seem a bit far-fetched. For now, we'll explain the most widely accepted theories, among them the one that suggests that the Earth was created when two intergalactic travelers collided in L5 of the cosmic supermarket. But let's try not to give too much away. Let's go on a new adventure into different possibilities of the origin of the Earth. Home sweet home. Yes, our beautiful planet Earth is a rocky terrestrial planet. It has a solid and active surface, with mountains, valleys, canyons, plains and more. Earth is special in that it is an ocean planet, with water covering 70% of its surface. Our atmosphere is mostly nitrogen, but it also has a generous helping of oxygen, so we can all breathe a giant sigh of relief. It also protects us from meteors that approach the Earth, most of which has a good sense to disintegrate in our atmosphere before reaching the surface as meteorites. Have you ever wondered why the sky is blue? Well, thanks to some of the theories of great scientists, we now know that it's because of something called Rayleigh scattering. Ideas like this have been approved for their consistency and possibilities, so even when it comes to the unknown, we can all rest easy. But in short, sunlight is scattered in all directions by the molecules of the atmosphere, and blue light is more scattered than other colors because of its shorter wavelengths. Let's start with the funniest theory of all, the one you've probably heard about the Big Bang. According to this theory, our universe began with a great explosion called the Big Bang. It is believed that before this event, all the energy and all the matter in the present universe was compressed into one point. With the Big Bang came the release of this energy, as a result of which all the particles of matter began to form and rapidly move away from each other. Can you imagine the whole universe being contained into one tiny point, so minuscule it would take a microscope to find it? Before the Big Bang, scientists speculate that the entire universe was compressed into a tiny, hot mass just millimeters away. Wow, talk about a small world! It seems like it only existed for a tiny fraction of a second, so I guess it's a good thing that it ended up expanding. It's mind-boggling to think that this was all once possible and really makes you wonder what other crazy concepts could be out there. The most shocking thing after the explosion, which broke the universe 13.7 billion years ago at a blazing 100 billion degrees Celsius, was that matter was present in the form of positively charged particles, called protons, and uncharged neutrons. Experts called it atomic dating. These particles took their chances and collided with each other, forming the first atomic nuclei ever. Talk about a cosmic blank date. Later, when the universe reached a temperature of about 2500 Celsius, the protons present in the nuclei began to attract small negatively charged particles, called electrons, which had an anchoring for creating the first atoms. And with these atoms, all the planets and stars in our universe were made, including our Earth. Now, there is also the nebula of planetesimal theory, which was developed by Immanuel Kant, and Simon Laplace was the first to discover this theory. According to this theory, everything began with the Big Bang of a supernova, and it was there that the solar system was born. Then, after the colossal explosion, the particles of the supernova formed an impressive disk, in the middle of which the sun gleefully shone. Inside the disk, there was collisions and mergers of particles known as planetesimals, who are just trying to figure out their place in the world. After a few billion years of bumping into each other, they finally managed to form large rocks, which ended up becoming the planets, satellites and meteorites of the solar system, all of which were 4.5 billion years old. This theory from the French astronomer and mathematician Pierre-Simon Laplace has been around for centuries, and it basically boils down to this. We all started from a big rotating nebula that, like a black hole, sucked in its own gravity and formed a disk with a nucleus at its center. It's pretty wild stuff, but don't worry, we all have been originated from there. Subsequently, when it reached a phenomenal rate of spins, the nebula had a meltdown and threw a series of rings in all directions, which, when they landed, miraculously created all the planets and moons. Meanwhile, in the epicenter of the nebula, the Sun was formed, and the planet began to revolve around it. This particular theory was developed in 1944 by the Russian geophysicist Otto Schmidl, which is based on the origin of the planets and the solar system from the accretion of cosmic dust. According to this theory, the Earth was formed about 4.6 billion years ago by a process of accretion of cosmic material. To be clear, accretion is a process of accumulation of materials on a given surface or around the core of a mass. As the Earth stratified into a core, mantle and crust to this process, it was bombarded massively by meteorites and asteroidal debris. This process increased the Earth's internal heat and melted cosmic dust, causing the eruption of volcanoes and many other processes that gave rise to the oceans, the primordial atmosphere and life on Earth. Speaking of oceans, you may have never wondered, but do you know where the salt in the oceans comes from? Why is seawater salty, with the water in lakes and rivers is fresh? Let us explain it to you in the simplest way. Seawater is salty because it contains a high concentration of dissolved mineral salts that are deposited in the rivers that flow into the oceans and seas. These minerals salts are the result of the erosion of rocks that have been deposited in the sea over the years, causing it to reach a salinity index. This theory was introduced by the English scientist Edmund Halley. The process begins when the carbonic acid present in the rainwater comes into contact with the rocks. This chemical compound, formed by the mixture of carbon dioxide from the air and water, has the ability to erode the rocks on which it falls. It's like a natural game of rock, paper, scissors. The rock lose, and the ions end up in the rivers, and then eventually the sea. It is a fitting process, in a way. The salt from the rocks erode, flow into the sea, and voila, the ocean is now salty. Who knew nature could be so clever? In addition to this deposit of weathered rock, there are other secondary phenomena that contribute to the salinity of seawater, such as water evaporation, volcanic eruptions, thawing, and hydrothermal vents. You may be familiar with Roger Penrose's name, as he won the Nobel Prize for Physics in 2020 and was probably the only person who understood what it meant. But if not, we'll explain who he is and what his idea is. Penrose is one of the living scientists who has theorized the most about the origin of the universe and proposed a theory that the universe goes through cyclical periods of expansion and contraction. Therefore, we are going through a period of expansion, as he explained in this article in The Conversation. The period of limiting contraction would be known as the Big Crunch, which would be mathematically identical to the Big Bang and would precede a new expansion. If that were the case, would we ever escape an end? Well, if Penrose has anything to do with it, we'll be getting an endless cycle of Big Bangs and Big Crunches for years to come. It is also important to note that within this theory, Albert Einstein speaks of a similar model. For example, he considered a model in which the universe followed an eternal series of oscillations between the Big Bang, the Big Explosion, and the Big Crunch, the Big Implosion. After the Big Bang, the universe would expand until the gravitational attraction between galaxies slowed the expansion and caused it to collapse, the Big Crunch, until it was compressed enough for a new Big Bang to occur, of course. A rebound effect sometimes called the Big Bounce. We are basically talking about the same thing. The Big Bang would be like the start game button, while the Big Crunch would be like the reset button, where the universe as we know it will be crushed back into oblivion. All of the hundreds of light matter, organic and inorganic materials, black holes, planets, stars like the sun and more would be gone in an instant. But it wouldn't be the end. It would be like starting over in a video game. Nothing ventured, nothing gained. According to this theory, there will be a plethora of universes, and ours will be just a tiny piece of the multiverse puzzle. To make the multiverse theory work, we must accept that there are a minimum of 6 dimensions. We only experience 3. However, some physical theories, such as string theory, which could be called the theory of everything, suggest that there are a whopping 11 dimensions, and that they're absolutely bonkers. In 2014, a team of scientists detected something that confirms the theories of cosmic inflation, warps in space-time caused by the Big Bang, suggesting that we actually live in a multiverse, a universe with many universes. You could say that our universe was bang on about that Big Bang 13.8 billion years ago. Finally, there is one theory that has not been completely dismissed by the scientific community, and that is the possibility that we are living in a kind of matrix. For example, an MIT cosmologist named Max Tegmark claimed in 2016 during a conference in memory of Isaac Asimov that the mathematical laws that govern the universe could actually have been created by an algorithm made by a higher intelligence, or even, to really blow your mind, that it is the humanity itself from the future that created the simulation to relive the past. Talk about a time travel paradox. It is also conceivable that other clever civilizations have constructed this simulation universe, either for educational purposes or just for a bit of amusement. This last concept is probably the most debatable of all, and we have no proof to back it up, but it's not totally out of the question. Avi Loeb is a stellar astronomer, and by stellar, we mean he's out of this world. As a former head of the Department of Astronomy at Harvard University, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and a member of the President's Council of Advisors on Science and Technology. Loeb is certainly no ordinary astronomer. He has even proposed the wild theory that our universe may have been created by a civilization more advanced than our own. We just have to hope they didn't make any mistakes. If Loeb's theory is correct, then it seems we are all part of a grand experiment. We could be the lab-grown creation of a highly advanced civilization, or perhaps we created ourselves. After all, with a flat geometry and zero net energy, it is possible that quantum tunneling could be used to create a baby universe out of nothing. So if you want to look at it in a humorous way, we may all be test tube babies. Today, there is a plethora of out-of-this-world theories about how the universe and Earth came to be, from a vacuum fluctuation to a cycle of contractions and expansions, to being selected by the anthropic principle to the multiverse string theory. The possibilities are endless. So which one do you prefer? If you ask me, I'm a big fan of the whack-a-mole theory. Every time a new universe appears, a giant cosmic mallet appears and smashes it back into nothingness. Thanks for watching this video and see you next week on this same channel.